All right, Unit 2, Lesson 5, Multiplying and Dividing Rational Expressions. When we are multiplying or dividing rational expressions, we do the same thing as when we're multiplying and dividing fractions. Okay, don't need a common denominator, just multiply the numerators and multiply the denominators. Or when dividing, flip the second fraction upside down. It is in our best interest to simplify as quickly as possible. We can cancel things out before we multiply. And then remember the rules with multiplication. We multiply the numerators. We multiply the denominators. And we simplify if possible. With division, we flip the second fraction. And then we follow multiplication rules. Okay, number one, simplify and state the restrictions. So first thing we want to do is try to cancel things out. So when you're multiplying, you can just look at your numerators and denominators. So we can see in this first one, 6 and 5, can't do anything there. But we have x squared and x, so we can cancel out the x and the squared part. In the second fraction, the x's can cancel. The y3 can cancel, which takes 3 out of the bottom exponent and leaves it with 1. So really we're working with 6x over 5y multiplied by 15 over 8y. Okay, multiplication, just multiply the numerator, 6x times 15 is 90x, 5y and 8y is 40y squared. We can simplify further. Both the 90 and the 40 divide by 10, so we'll be left with 9 and 4. Numerator is x, denominator is y, so we can't do anything further there. So our final answer is 9x over 4y squared. Okay, as for restrictions, we go right back to the original statement. 5xy means 5 times x times y. That means neither x cannot be 0, y cannot be 0. Because if either x or y were 0, that 5 times 0 times something would give you 0, cannot divide by 0. Okay, so that was a pretty simple one. Everything was factored already. What if we have to factor? So just like simplifying rational expressions like we did last lesson, we are going to do the same. So the first numerator we have here is a difference of squares. So it becomes x plus 2, x minus 2. Okay, our denominator, we're going to just separate the squared into x plus 6, x plus 6. We're going to separate the brackets. Okay, in the right fraction, we would do some simple factoring, and once you're done your simple factoring, we would figure out that our factors are x plus 6, x plus 3, so I skipped doing it there. 6 times 3 is 18, 6 plus 3 is 9. That's how we factor that. And then at the bottom, we want to end up with positive x, so we're going to take out a negative 1 from the bracket. So we end up with negative 2x minus 2. Okay, now we can start canceling, so we have an x plus 6 there and there, an x minus 2 there and there. And that's it for the same thing, so we end up with x plus 2, x plus 3 over x plus 6. Oh, sorry, negative 2x plus 6. Okay, and that's as far as we can go there. If we look up to our second step, we know that this x value is negative 6. This one is positive 2. So therefore, x cannot equal negative 6 or positive 2. Okay, the next one is going to involve some steps. Okay, so we're going to have some steps here. One, we're going to rearrange into ax squared plus bx plus c. Then we're going to factor. Step 3 is to cancel, if you can. 4 is to simplify. And the last step, 5, are the restrictions. Good, so you're 5 steps. Okay, so step 1, we're going to rearrange. So we have negative 3p squared plus p over 4p squared plus 16p divided by p squared minus 9p plus 14 over p squared plus 7p plus 12. Okay, before we worry about the division, let's factor everything. So the top one, first numerator, we could take p out, common factor, and we're left with negative 3p plus 1. And we can common factor out the denominator on that one too. We're taking 4p out, so we're end up with p plus 4. Okay, numerator over here, simple factoring. 2 and 7 multiply to 14 and add to 9. So we're going to have p minus 2, p minus 7. 3 and 4 multiply to 12 and also add to 7. So we're going to have p plus 3, p plus 4. Okay, and then before we start canceling, we have to fix it. It's division. How do you divide fractions? You flip the second fraction upside down. So I'm just going to rewrite the first fraction. And I'm going to change it to multiply and flip the second fraction upside down. Now we can look for similarities. We have a p plus 4 and a p plus 4. And outside the brackets, we have a p there and a p there. Okay, so, wrong button. we end up with, on our numerator, negative 3p plus 1 and p plus 3. The denominator, we end up with 4, p minus 2, p minus 7. Okay, we look for all of our restrictions, so that's the final simplified answer. Our restrictions, we have 0, negative 4, negative 3, and then once we flipped it, we have positive 2 and positive 7. Okay, so therefore x cannot equal negative 4, negative 3, 0, 2, or 7. Okay, we extend on to a more difficult one. First thing we want to do, everything's in the right order, so we're just going to start factoring. Complex factoring of 2x squared plus 5x minus 3. You should end up with 2x minus 1 and x plus 3. On the bottom we have a common factor of x, and we end up with x plus 1. Okay, that multiplied by complex factoring will give you 2x minus 1, 3x minus 4. And on the denominator we have 2x minus 1, x plus 1. And then we divide that by, take out the 10, x plus 3. Common factor at the 5x, we have x plus 2. Okay, now I'm going to rewrite everything and get rid of the division sign. Because we can't start factoring out or canceling out until it's all in the right order. Okay, so change it to multiplying. 5x, x plus 2 is the new numerator, and 10 times x plus 3 is the denominator. Okay, so we can start canceling. We have a 2x minus 1, 2x minus 1. And we have an x here and an x here, and a 5 and 10 turns to 1 and 2. And that's all that we can do. So we end up with x plus 3, 2x minus 1, 3x minus 4. Oh, my mistake, we had an x. We also had an x minus 3 that we could cancel. So I'm going to put the x plus 2 that's left over. Sorry about that. And on the bottom, we have number 2, x plus 1, x plus 1. Okay, our restrictions. So this has a restriction of 0, minus 1, 1/2, negative 2, and negative 3. So therefore x cannot equal negative 3, negative 2, negative 1, 0, or 1/2.